The oil that keeps the calculation engines of physics running smoothly is the system of units that is used to measure the different quantities in physics. Now, most countries have adopted the SI unit system, or Système International, and this is made up of several base units which represent quantities that we can measure, and other combinations of those base units. And it's important that we're able to connect the symbols of these units with the quantities that they represent. So here's a little flashcard to jog our memories as to what all of these symbols mean. And we're going to dive in, first of all, by identifying the 4 base units that we're going to look at, and then we'll look at the derived units that they represent as well. Okay, let's first of all start off with kg, which is kilogram. Now, a kilogram is a measure of mass. So there we are, just put the kilogram on the side there. Note that kilo is a prefix, and that means 1,000. 1,000. So there are 1,000 grams in a kilogram. Moving on, we've got m, which stands for meters, and that is a quantity called length, measures distance. And so we'll put meters here, that's the unit. So these are the units, and these are the quantities. Quantities are in green, units are in purple. Let's move on to another base unit called the ampere. Now, the ampere is a quantity called current. It measures the flow of charge in an electrical circuit, for example. And so the unit is called the ampere, and that's a French name, amp for short. One more base unit, or SI base unit, which is S, which stands for second, and that's the quantity of time, passing of time. So that's second. Okay, now we're going to look at the derived units that are combinations of these base units. Apologies if you can hear my dog in the background. I think somebody's arrived. So we have N is a symbol representing force, the quantity of force. And that is a unit called the Newton, after Sir Isaac Newton. And we have meters per second. Now, meters per second is telling us how fast something is moving, distance per time. So this is speed. Whoops. Speed or velocity. Now, velocity is just speed, but in a certain direction. So they have the same units. I won't put meters per second on the side because we've already just covered m and s. What about this one then? M per second squared. So this is telling us how fast something is speeding up. It's the acceleration. Acceleration of a body. And this one over here, meters cubed. Well, that's volume. There's a measure of space, if you like. Meters squared is area. Area. And now we come on to the not so obvious ones. We've done newtons, which is not so obvious, but this one, joules, is representing the quantity called energy. And so we need to put the unit is joules. And right, what about this chap here, W? W stands for watts, and that's the quantity of power. Power. So this is a watt, and it's telling us how many joules are being transferred every second. It's the power of an appliance. That leaves us with one more. Here we are, grams per centimeter cubed. Now notice that we're using grams, not kilograms, and centimeters instead of meters. Don't worry, it's just a smaller version of the base unit. Instead of being a kilogram, it's a gram. It's 1,000th of the size. And instead of a meter, it's a centimeter, 100th of the size. So this unit is telling us that it's mass per volume, how much mass there is in a certain volume. And that is the quantity called density. So a bag of feathers is much less dense than a bag of lead. Grams per centimeter cubed. So there we are. There's a good summary of units to memorize. So you can link the symbol with the name of the unit with the quantity.